In this video, I'm going to go over the simple problem of binding energy. The binding energy is the energy you have to supply to a nucleus in order to disassemble it into individual protons and neutrons, which means that the separated nucleons have relative greater mass than the nucleus because the nucleus plus the binding energy equals to the separated protons and nucleons. So the oxygen isotope has 8 protons, and which means it has 8 neutrons, and it is relatively stable. And it gives us the atomic mass of protons, neutrons, and electrons because the atom consists of the nucleus and the electron cloud. So the first step is to calculate the actual mass of the nucleus, which you have to minus the electrons in order to find out the mass of the nucleons. There are 8 electrons because there are 8 protons. Again, it is a stable isotope, so if there are 8 protons, there are 8 electrons, and the former one have positive charge and the latter one have negative charge. So the actual mass is approximately to 16, but not quite 60 because there are 8 electrons. And the mass of nucleons are the combination of 8 protons and 8 neutrons, which is 16.132 atomic mass per U. The mass defect is the difference between the actual mass and the mass of the nucleons, which is a little slightly 0.1369 atomic mass per U. So in order to calculate the binding energy, we have to use E equals mc squared, but as I covered before, we have already transformed the formula. So we have to write it in MeV per U. So the binding energy is the atomic mass in U, unified unit, times the energy per U, which is 127 MeV.